Good afternoon, good day, everybody. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Today, we are taking a topic in mathematics, and that topic is under calculus. And the topic is differentiation of a given function from the first principle. The function we are differentiating today from the first principle is function of a sine of a variable x, that is independent variable x. So for instance, now let's say we are given this function y is equal to sine x. This particular sine is measured in radian, not in degree, please, for this our work to work. Now from the first principle, let there be an increment in x. The moment there is an increment in x, there will be a corresponding increment in y. This can be shown, like for instance, let's say this is the graph, the sinusoidal curve for sine x on the vertical axis against variable x on the horizontal axis. Now, when I move from this point to this point, let's say at this point is x1, then at this point is x2. There is a change in x when we move from x1 to x2. Now from y1 to this y2, there is corresponding change in y. So that's why we say when there is a change in x, this change in x will produce corresponding change in y. So this change in x will produce corresponding change in y. So that's the idea. So now when there is a change in x, there will be a change in y. So I write y plus change in y is equal to sine x plus change in x. So we make change in y, solve the formula, then I have sine x plus change in x, take away y. So change in y will now be sine x plus delta x minus, since my y is sine x, so I will write a sine x there. Now this particular difference, this trigonometric difference that I have here, this trigonometric difference that I have here, if you look at it very well, is related to compound angle. Recall the compound angle for sine. Sine A plus B is given as sine A cos B plus cos A sine B. And then sine A minus B is given as sine A cos B minus cos A sine B. Now, since I'm doing difference, I'm going to subtract this one down from this one up. In this case, my x plus delta x is A plus B. So A plus B is my x plus delta x. In this case also, my x is A minus B. So A minus B is actually my delta x, sorry. My delta x, sorry, it's my x, that is A minus B. So take note of that. So in this case now, this place says we should subtract this from here. When we put minus there, the minus we change this parameter that we have here. You know, when will I say this one, sine A plus B, take away sine A minus B. Let me write it here. Sine A plus B minus sine A minus B. You know that this is sine A cos B plus cos A sine B. Then this is sine A cos B minus cos A sine B. So what we have here now, when we subtract, I'm going to have sine A plus B minus sine A minus B. The subtraction here we have had this place. So this one, when I add them together, when I subtract them from each other, this one become 2 cos A sine B. So become 2 cos A sine B. So in a nutshell, what we have here is the same thing as what we have here. So I'm going to now get expression for A and B in terms of x and delta x. If you look at this place now, when I add this together, the b will cancel out. I have 2a. So I have 2a. When I add this together, I'm going to have a 2x plus delta x, making a solve the formula. I have 2x plus delta x divided by 2. Now, to be able to get my b, I'm going to subtract this one from this place. When we do subtraction, the sign changes. So when I subtract this one from this place, I'm going to have a delta x. So that means 2b is going to be delta x, which implies that b is equal to delta x divided by 2. So I can rewrite this one now that I have here. I'm making reference to this expression here. So you can write sine x plus delta x minus sine x. You can rewrite it in this form as 2 cos. For my a is 2x plus delta x over 2. 2x plus delta x all over 2, then times sine delta x divided by 2. So this expression I have here is actually delta y. Since I'm looking for delta y all over delta x, the limit of it as delta x tends to 0 to give me my dy dx. That means I need to divide both sides of this expression by delta x. Therefore, delta y divided by delta x is going to be 2 cos 2x plus delta x divided by 2 times sine delta x all over 2, then times 1 all over delta x. Division of this with delta x means times the inverse of delta x. Now, you should recall something, that when we have this standard limit of sine x all over x as x tends to 0 is equal to 1. We can relate that to what I have here. So I can take these two here first. I have cos 2x plus delta x divided by 2 times sine delta x all over 2. These two, I put it here, then times 2 all over delta x. Now, for me to be able to have an expression of this division, I can convert this one to division so that whatever that is up here will be down there. So what I'm going to have now is going to be cos 2x plus delta x divided by 2, then times sine delta x all over 2 divided by, if I say divided by, then this times means this one will go up, this one will come down. So the times when it's changed to division, this fraction will be rewritten so that I have delta x divided by 2. So this can be rewritten as cos 2x plus delta x divided by 2 times sine delta x all over 2 divided by this division sign, delta x all over 2. So that is my delta y over delta x. So limit of delta y over delta x as delta x tends to 0 is equal to dy dx. So which is the same thing as, since this one tends to 0, I will be left with 2x over 2. That is a cos 2x all over 2 times limit as delta x tends to 0 of this expression, sine delta x all over 2 all over delta x all over 2. This particular limit I have here is related to this standard limits that I have said here. So this particular one become 1. So therefore, limit of delta y all over delta x as delta x tends to 0 is equal to dy dx times these two cancel these two. So I'm left with cos x times this one, because this limit become 1. So everything become cos x. Therefore, for y is equal to sine x, dy dx is equal to cos x. So this is the proof of when we are given y is equal to sine x to find the y dx. This is the proof of it. Thank you for having your time. I believe that you must have learned one or two things concerning the illustration on how to find the derivative of the sine function. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please do not forget to like, share, subscribe, and click on the notification button to have more of my video. The essence of sharing is for this presentation getting to the targeted audience. Have a nice day. Thank you. Bye.